This is going to be a short video on an introduction to what's called dimensional analysis. I'm going to tell you that a lot of you are going to try to do this a different way. Eventually, almost everybody I've had in class has eventually gone to this. First time I was taught this was probably in I don't know, 10th or 11th grade. In high school, again, I thought, what is this? But I used it in college in every science class I took, particularly physics, chemistry. I used it in calculus. It's an easy way to solve problems without having to think a whole lot. So it may look a little foreign to you at the beginning, but it takes away a lot of the thinking when you're doing a lot of math problems. So here's kind of the premise behind it. So I've got these two conversions. A kilogram is that many pounds. A pound is that many kilograms. So essentially they're the same conversion, just written a little bit differently. So if I say that you have a weight of 125 pounds, and I say, what is your mass in kilograms? I can use either one of these conversions. The thing you have to know is, do I need to multiply or do I need to divide by the number? So if I was using this one, I have to know, okay, do I need to multiply by that or divide by that? And a lot of us can do that in our heads and know what to do. This is a fairly simple problem. It's a one-step problem. But if you're not sure, and a lot of times kids think they know, and then they're wrong. If you're not sure whether you need to multiply or divide, dimensional analysis will help you. Okay, it will make you do it the correct way. So if I was using this conversion, so ignore the second one. If I was using this conversion, I was either going to divide by that number or multiply by that number, one of the two. So here's how I'm going to do this. I'm going to write this as a multiplication problem. This conversion factor goes in here. Okay, this is just over 1. There's nothing underneath there in this case. So I'm going to either put the 2.2 pounds on top or on bottom, and the 1 kilogram goes the opposite spot. So the two things that go in here are always things that are equal to each other. It's called a conversion factor. 1 kilogram is equal to 2.2 pounds. The way I know what goes on the bottom is whatever label is here goes down here. I want my labels to cancel. So on this big fraction, don't think of it as a fraction too much, but I have pounds on top, pounds on bottom. So kind of like if you have 5 divided by 5, they cancel, become 1. Pounds over pounds, those labels are going to cancel. So since pounds is down here, that means I'm writing the 2.2 down here. That means I'm putting the 1 kilogram up on top. So what that tells me is, this is again a multiplication problem. I'm going to multiply 125 times 1 divided by 2.2. So my labels told me I needed to divide by 2.2, not multiply by it. These labels cancel. The labels are gone. The numbers are still there, 125 and 2.2. The label we have left is what we wanted. We wanted to get to kilograms. That label should not be canceled, and it should be on top. If it's on bottom, we had a mistake. So we would take 125 times 1 divided by 2.2. So you're always multiplying on the top, dividing by the numbers on the bottom. Okay, so that's about 91 or 92 kilograms. I think it's about 91.4. Now, what if I would have used this conversion? Same thing. If I start with 125 pounds, again, I immediately know that my label needs to come down here. Whatever label's up here has to go on the bottom over here, or they cancel. If I had pounds on top there and pounds on top there, it becomes square pounds, which is no such thing as a square pound. So now I'm putting this conversion in. So 1 pound is equal to 0.4545 kilograms. Pound cancels. I'm multiplying 125 times 0.45. It's just a 1 on the bottom, so I'm dividing by 1. And I should get the same answer approximately, about 91 kilograms. Okay, so in one case I multiplied 1 and divided. So if you're not sure, do I multiply or do I divide? My label will tell me. As long as my labels cancel, the one on top and one on bottom cancels, they work out. Let's do one more problem. And you should have a conversion sheet. Hopefully you've got this little conversion sheet again that's got lengths, volumes, and masses. So I'm looking off of that, but I'm going to do, if you have a half a mile, and I want to know how many centimeters that is. So this is actually, on this dimensional analysis conversion sheet, it is actually number 4 on there. The one I did before that was actually number 6. Sorry. I'm a little out of order, but so if I want to get from miles and I'm trying to get to centimeters, so think about that for a minute. A mile is very, very long, a centimeter is very small. There's going to be quite a few centimeters in a half a mile. So the goal here is labels have to cancel. So I'm going to multiply or divide by conversion factors here. Just make sure labels cancel. So whatever label's here goes down here, not the number, just the label. So I'm trying to get from miles to centimeters. Well, this sheet doesn't have anything directly from miles to centimeters. There's several ways we can get there. It's got miles to kilometers. It's got miles to feet. Okay, there's several of them. Let's just go miles to feet. So 1 mile is 5,280 feet. So 1 mile is equal to 5,280 feet. Label cancels, label cancels. So if I would take a half times that, times 5,280, that would tell me how many feet are in a half a mile. Well, I want to get to centimeters, so this label is the one that's left. It goes on the bottom. So my labels will cancel. We can go feet to inches. A foot is 12 inches. Foot cancel. Left with inches there. Again, if we stopped right now, we'd be at inches. We want to get to centimeters, so put inch on the bottom. And there's a conversion on the sheet from inches to centimeters. And every 1 inch is 2.54 centimeters. So inch cancels, inch cancels. When you're getting these answers to these problems, multiply across the top, divide by each number on the bottom individually. In this case, they're all ones in the bottom, so you don't have to divide it all. But a half times 5,280 times 12 times 2.54. So I do not. It's 80,450 centimeters. 80,000. Again, the label you wanted to get to should be on top, not canceled. Again, that was questions 4 and 6 off your dimensional analysis conversions. I'll put some of the other ones on different videos.